to take a couple of minutes to go over ranging with your reticle and using the subtensions. The first thing you're going to need to have is a calculator handy, and then you're going to need to get the program up and opened up. And I originally bought this program for my son when he was starting to compete, so that he could learn the skill and I could save some money. Anyway, at the top is a section of buttons that you can click to kind of learn more about how to use it. We're going to fast forward. We're going to use a bullet that drops enough and gets pushed around by the wind enough that it gives us some practice. We're not going to choose a 300 Win Mag, because the idea is not to hit the targets but to understand how to range better. We're going to use a 72 by 19-inch target. In general, the larger target at the same distance, the easier and more accurate the read is. Once you learn how to range real well, then you can go into some of these other modules. The angle of fire exercise will allow you to take that range estimation that you made, look at the angle, and take the cosine of that angle, times it against the range estimate you made to get a new gravity distance, and that's what you'll use for your dope. But of course, first things are first, we need to know how to range well. So we're going to go ahead and click Mill, and then open up the program or drag the corner to make it a little easier to read. The first thing that comes to mind is that this looks like a Kestrel to me, but the main difference is that this is like a weather vane on a barn or your house. It points into the wind. So the wind would be coming from the north to the south at the top of the page to the bottom, and the point would be swinging into the wind. So in your program, you would enter, if you're using the clock system, that it's coming from 12 o'clock or it's at 0 degrees. And then we have the range card underneath it. And again, the range card is very coarse, but it's not so much for hitting the target. It's again for determining the size of the target is what the exercise is about. To the left, we have some bullet data that you can enter into your ballistic solver if you want to follow along and kind of gain the skill and practice. And I recommend it. It's useful, but it's only going to track well for the first 600 yards or so. And then they made up a calculations formula for you so you can follow along and don't have to look it up. So we'll go ahead and click the stages. That will bring up your reticle with the turrets, and there's going to be 3 scope choices: a 10 power fixed, a second focal plane, and a first focal plane. There's also 3 scope choices: your oval mil dot, round mil dot with half mil ticks, and the mil line. We're going to use the mil line reticle. All 3 of the scopes use a center on center measure. So the center of the dots or the center of the lines on the large lines here are going to be 1 mil apart with different subtensions based on the size of the dot or oval. And in this case, different subtensions are scaled on the sides and tops and bottom of this reticle. So we're going to go ahead and take the horizontal strata line, just lay it kind of hopefully parallel to the, sorry I'm having a little bit of problem here, parallel to the head of the target, or kind of like, so it's bisecting the line. And then we're going to kind of see how tall this target is. And this target appears to be 1, 2, 2.5, 2 3/4 mils when scaled on this reticle. So if I go to the 10 power, you'll see that everything got smaller, including the reticle, but the scaling is the same: 1, 2, 2.5, 2 3/4. When we come back to the zoomed in version, we notice that we will find a distinct difference when we hit the second focal plane. Most people default to these types of reticles because they're cheap and they look cool, but they don't necessarily work so well for ranging quickly at a multitude of zoom ranges. So here you can see that this is telling us it's 1, 2, 3, 4, 5 plus something in terms of height. So it looks like it's it's like 5.6 is what this read is giving us. So one of these 3 scopes is wrong, and at this zoom range, this second focal plane is not scaling correctly. So that's where the problem lies. So again, if you wanted to quickly range something, you could just drop down the top of the strata line and kind of, roughly estimate the height of the target, or the scale of the target, how many mils it's taking. But there are other better ways to do this when you have the time to do so. So in this case, I'm going to go ahead and zoom in a little bit and move the target over so you can see it. And we'll see that I can't tell if I'm sitting on the top of the target, sitting underneath the top of the target, or what I'm doing. And in this case, what I want to do is I want to use the more detailed section of this reticle anyway. And so I'm going to take advantage of the first tick mark that I can see, full mil. That still keeps me inside of that this lower set of finer resolution. And I'm going to take it so that I can see that the top of the target bisects the center of the line or dot or whatever else I'm using. And so center on center, I would have 1, 2, and then I have these are 5 different lines. So it's taking the 1 mil, breaking it into 2/10 of a mil. So 1, 2, 2.2, 2.4, 2.6, 2.8 is what I get when I'm able to use this finer resolution, not 2.75. So let's zoom back out and use that in a solution. Okay, so we should write it down, 2.8. And what we're going to do is we're going to come over to our equations chart, and we're looking for range in yards. And we're going to put the size of target times a constant. Now the constant here is shown is correct. A lot of people use 27.78. I use 27.77. And the reason I do is if I'm going to round down a bit, because generally optical disturbances make the targets kind of shimmer and appear larger than they are at long range. So that's what I use, and I find that I'm almost 10, 15 yards higher anyway, just because of the optical disturbances. So that's what we'll use for now. So 27.77, the military also uses that, but for different reasons. So size of the target in my calculator, 72. I'm going to times that inches times my constant, 27.77, and I end up, under 2,000 here. If I were to use that 27.78, I'd be over 2,000, so I would have a further shown distance. Now I need to divide it by that number that I wrote down, which was 2.8, although I didn't write it down, I should have probably, and I get a estimated yardage of 714 yards. So let's go ahead and just drop the target centered up on center mass, roughly center mass, and then look at what 715 looks like. So if I come down here, I have 700, I don't have 715. If I had 725, I would probably try to split the difference here with a guess. As I get longer in range, I'm going to shade towards the shorter range. So in this case, if it was 700 and I guess and I had a 725 read, I'd be closer towards the 5.8 than I would towards the 6.0 in terms of my choice, even though the range is right in the middle, because the bullet begins to drop more and more severe. So in this case, we're only 714 yards out, pretty darn close to this 700. But I look at the temperature that I originally had set for this sheet, and it's nowhere close to where we are. We're at 106 degrees with a 5-mile-an-hour wind out of about 2 o'clock. So I think this is going to shoot definitely like 700 yards. It's going to shoot 10 yards narrower, maybe even less. So I'm going to probably just use that 5.6 number. And for wind, I got 5, so I would times 5 times this. So I have about a half a mil of wind hold. Generally, you're going to write here on your ballistics chart, it's going to be for a 10 or 5, whatever mile per hour. Full value wind means coming across left to right or right to left, and you quarter or half the value from there. But this one is already, looks like it's adjusted. So I need to adjust my turret for hold. I don't only have 5 mil to hold, so I'm going to adjust the turret to 5.6. So I'm going to opt for it shooting 10 yards shorter than what my read is because of the heat. So I have 5.6. Now, you could enter the value for the wind, but I'm going to just take it. I think I want a half a mil. So I'm going to take that half mil and just center it up. And remember, I have to go into the wind because the wind is coming this way. So I have to cheat into the wind. Now, I'm off the plate here. This is giving me a lot of margin left and right. In some cases, if the plate was you know, maybe a little bigger, I might cheat more to make sure that I still would hit the plate if I wasn't sure if I had a real gusty wind. But there's nothing about this that tells me I have a gusty wind. So I'll go ahead and just, you know, leave it right there. So now I have a 5.6 dialed, which is a 700 because of the heat instead of 714, and I'm holding my wind. You can pull the trigger here and you'll see where the miss or hit is. So you pull the trigger, you'll hear a noise, and then in the lower left-hand portion of your screen, it'll show you where you got the hit. So in this case, it looks like elevation-wise, we guessed really well, okay, because of the heat. So let's try a new target, and we'll try a different strategy for the holds on this target. So this target is obviously a little further away, and if I go to do the same thing with milling, you'll see that I kind of have to, I can't use that full, well, I guess I can. So we'll go ahead and zoom in to show you this and see what we get for scale. All right, so I set it just about right. So it looks like it's 1, 2, and this is 0.2, so 2.1 is the number you'd want to write down for your scaling. So it's 2.1 mils. So to just repeat the process, we have the 72-inch target, or whatever distance your target happened to be, times your constant, 27.77, and that should equal the same as the number it did before. We're going to divide it by the 2.1 mils that we just scaled, and we get a distance of 952 yards. Now, the further it goes, the distance is, the worse chances you're going to have of getting an accurate read. It just becomes, you know, more and more difficult. So let's try something different. In this case, let's go ahead. We dialed for elevation completely. Let's dial 6 in the turret. So up here we have 6, and we'll hold for the rest. Now, in your case, you have horizontal strata line that go across here, so it's very easy to get your windage. In this case, we're going to have to really guess, and we're going to float in Never Never Land. So I have 952 yards. We'll use the 950. So I suspect a couple of things. One, the heat again is really going to come into play. And if we look, we're at 9.5. So I pulled back a couple of tenths for the heat before. So now I'm going to need to pull back at least a couple of tenths here. So maybe 9.3. So what I could do is dial 6.3 for elevation, and I can hold on my strata line. The reason for this is just speed. I could have left it where it was and done the math, and really just to show you another way for the hold. So I'm going to go up to 3 because I have to add 3. 3 plus 6.3 is 9.3. So I'm centered up, but I have no windage dialed in. Okay, so 1, 2, 3. Now for my windage, again, I got to cut this back a little bit because of the heat. So this is saying I get 2 tenths for every 9 miles an hour. So I have roughly, 1.8. I'm already thinking that my 9.3 might be a little hot, might be a little too much. So, but I don't think it's going to be 1.8. I think it's going to be more like 1.3, 1.4. So go over here again into the wind, 1, 1.5. So I'm guessing it's right about here, and I'm going to take that and kind of scooch it over. Now again, here's where it comes hard to guess because I'm holding off in Never Never Land. Yeah, see, I can't even really see here for sure. Well, you'll have these lines that come across, and we'll have your tick marks to give you exactly what you're looking for. So elevation is 9.3, 9.2 is what we should be holding probably. So 1, 2, 3. 1, 2, 3 plus what we dialed. Okay, so we're sitting at 9.3, and we have our 1.3-ish, okay? So I'm going to go ahead and fire and see where it hits. Okay, so we did get a hit, and if we look, I could have held a little bit more for the wind, so maybe it was a 1.5 hold for the wind. All right, so let's do the next one and miss intentionally. All right, so now we have another target, and we know just now that we've scaled it a couple times, we know that 2.1 is 950, right? And so we know that this target is 1, 2, 2.5. It's under 950. It's less. So let's pretend that we had dialed that 9.2 that it looks like it needed to be. I said 9.3, but let's just do 9.2. Actually, let's take it back. We'll miss on the windage. We'll do one more exercise on scaling. So let's get it to where it was. Okay, we'll zoom in. But we're going to miss on this one, so purposely miss. All right, so we're going to scale this. 1 mil, 2 mils, 2.2, 2.3. Okay, so the target appears bigger, so that means it's closer. And we're going to go ahead and that's how you kind of double check your work, right? So I think I said 9.3, I forgot already. So we take that 72-inch target times our constant, 27.77, divided by, did I say 2.3? So yeah, I should have wrote it down. 2.3, and we get a distance of 869. Okay, that is smaller than the 950 we had, so that sounds like it makes sense. Again, we have the high heat and a 6-mile-an-hour wind. So I'm going to say that 850 is probably pretty close. So 7.8, I will go 7.8. Okay. If it was normal, if it was the same temperature or colder, I would be cheating the other way. So now I dialed for the elevation. Now I've completely forgot about the wind. Okay. It's only 6 miles an hour, so if we're at 850, I should be missing somewhere over in here. Okay, so we're going to look for the bullet splash when we miss. Okay, right there. So if this were to happen anywhere in your scope, you take that, drag it to the center of your target, and come up with a follow-up shot hit. And it's really fast, really easy, and a great way to be able to know what you're doing. So if you look at the ranging, obviously it's come close because we've been hitting when we wanted to hit for elevation. But if you look right here, it will show you your meters and yards that the program thinks it set it up as, and it had 860. We ranged it at 869. The other one before that, I had 952. I think it was ranged at 940 something, and I had 714 on the first one, and it was ranged at 710. So all very, very close. And in some cases, it could be better than some of the cheaper rangefinders, and certainly even better than a rangefinder that's getting a bad bounce off of a bad surface. So let's do one more. We'll not range this one at all. I'm going to go ahead and drive this back down to almost nothing. Maybe I'll do like a 300-yard dope. What's 300 yards? 1.8 on this thingamajigger. Okay, so the idea is that we don't even really know what we are. We didn't scale it. I'm going to put it on the target, and we'll shoot and see what happens. Okay, it hit way down here. Way down here. So I'm going to shoot again. You'll see right down in this lower section, below the bush. Okay, so with the scopes that have these horizontal lines for the windage, people call them Christmas tree reticles, you would take where it hit, you'd hold right there, and you'd take that number, and you'd either dial it, okay, the new numbers, or you'd place it on the target, and you'd hit your target. So that's why these reticles that somewhat seem busy and some people may not like for target shooting are so valuable for the people that are out in the field, even for hunters or tactical shooters practicing. So hopefully this has been helpful. I wish it had a different set of reticles that we could try a couple of other things, but this is what we have, and give me a call if you have any questions.